Hey everyone, welcome back, and let's discuss another problem from our binary trees, which is connect nodes at the same level. This is your problem for today, which we will be discussing and solving at the same time. Let me just check if we guys are live. Yes, we are. Okay, so let us start off with the question. This is a good question. Again, I would say we have solved such problems a lot of times now in our previous questions of binary trees. So a little modification in that, and that will be all for this problem. So let's understand what we have to do. You're given a binary tree, connect the nodes that are at the same level. So we kind of have to create links between the nodes that are present at the same level. Okay, so with this you can think of something that, okay, I want nodes of the same level. So like we were doing the traversal level order. You remember how we were doing the level order traversals. A lot of questions we have done. Okay, this is just one thing. What we have to do, that the tree is as it is, you just have to do an extra thing, that each node on the same level must be connected via some link to each other, like we used to do in a linked list. So kind of you have to create a new linked list on every node by just connecting all the children nodes on that particular level. So for that you just need to have all the children of the same level at the same time, so that you can form the link. And the next thing is that the last node of that particular level, its next should be pointing to null. So if I talk about this 0th level, then one's next should be pointing to null, and the rest of the links remain same. This is left node, this is right node, this is left, this is right, all of these remain same. Only the extra thing is that you are adding an extra pointer which your class has already given you implemented in the class node, as I'll show you the question. So you can see that class node, earlier we used to have only two extra nodes, left and right, for our tree node, right? Here they have given an extra node, next, right, which we can use to form a link between the nodes of the same level. Okay, so like in linked list we used to do dot next, here we can do dot next right, which will be used to create the link between these nodes. Okay, so 4's next would be 5, 5's next would be 6, 6's next would be 7, and 7's next would be null. Okay, so that's what you have to do. Very simple thing, going to be very easy for you if you have already followed previous lectures. Hello guys, welcome. Sorry for being very late today, but okay. So what do we do in level order traversal? We take a queue, correct? We take a queue, we insert the root node into our queue. Now the next thing would be, every time I am inserting this element into my queue, right? So what do? We used to check while my queue is not empty. First I have inserted this node into my queue, and then I start with the loop while queue is not empty. Let me write the pseudocode. Okay, if this is the case, then what are you going to do? If queue is not empty, you are going to create an extra node here. Why? You will understand. Let's take an extra node previous, let's say, and let me point it to null. Okay, then I gather what is the size of my queue right now. Okay, so that is your queue dot size. Fine. The next thing is while n is greater than 0. So basically now for every node in your queue, you will remove that node, that will be your current node. So what will be the current status? So the node current is right now 1, this node 1. Okay, what I want to do, I want to form a link. So for that I will first check if my previous node, let's say right now I have a node previous, okay, and I can take one extra node. Let's take it as node, okay, no, node current I have already taken. If my previous, see, right now you will not understand, after 1 or 2 iterations you will understand. If my previous is not equal to null, then what do we do? If previous is not equal to null, you do previous dot next right. That means you are forming a link between your previous node. It's like a temp node you have taken, and there is the current node is the node which you have just removed from the queue. and then you are trying to form a link. So basically I'm trying to take a new node here, previous, which I have declared right here. For every level, this previous node will be declared every time. Okay, then I will iterate over that level via this previous node by forming link between from previous to your current node like this, and then I will make my previous point to current node itself, and that's how I will do. And finally, right now my previous will be pointing to null. I check if it is not null, then I will simply do previous dot next right equal to current, and if this is the case I do this. And even if not, one thing that I have to do is you make your previous point to current. So right now the situation is that my current and previous both are sitting at 1. Okay, both are sitting at 1. Fine. Okay, this is something that you do. Now the next thing is what? Same what we do in a level order traversal. Now you check, this is just the link formation we have done. Now you check if cur dot left is not null, then you insert in your q dot add, because it will be of type linked list. So I am adding q dot add cur dot left, and same check for right. If cur dot right is not equal to null, you insert right node of the current q dot add cur dot right. One more thing you have to do is that basically instead of this while loop, you use a for loop here. It will be better. Why? For I equal to 0, I is less than n, and I plus plus. Why so? Because I have to ensure when I am at the last node of that particular level, I want its next to point null. So I can keep a check if my I is equal to n minus 1. So what I want to do is make your previous dot next point to what? Null. That is something, sorry, current will be that node. Current dot next right should be pointing to null. So that, and then repeat the same process for all the other nodes. Let's do a dry run and you will understand. So it was the code is definitely a little bit lengthy. We have done this quite a few times now. So now let's do the dry run. You will quickly understand. So right now my current and previous both are pointing to this 1. Okay, I check only for one time this loop will run, because you only have one node in your queue, because the size of the queue at that time was only 1. Now from this line of code, from this and this, you must have inserted into your queue. Let me write it here. Into your queue you had 1. Now you have added 2 and 3 also, which are the left and right child of your tree. I'll create the tree once again here, so for a better visualization and the dry run that we are doing. Give me a moment. So this is 1, 2, 3, 4, 5, 6, 7. Let's say this is your tree. Okay, now what is happening? You have already removed this one. Current and previous both are pointing to this node, and now from this line of code, cur dot next right is pointing to null. This has happened as of now. Okay, now you go back to the while loop. You check your queue is not empty. This is the current status of queue. You again create a new node previous, which is right now pointing to null. Okay, cool. What is the size of your queue? The size of the queue right now is 2. So you iterate it for 2 times. You just create the links between 2 and 3 and add their corresponding left and right child for the next further iterations. So meanwhile, I am removing the peak element of queue will be this first node, which is 2. So right now current is with 2, right? So you have taken current at 2. Fine. Now if previous is not null, which is not the case here, you don't go into this condition. You make your previous and current pointing to 2 right now. Both are pointing to 2. Then next step is, if your current dot left is not null, basically you have inserted 4, and by the next line of code you have inserted 5 as well. Okay, fine. Then you commit this condition. Is it the last iteration of this? Are we at the last node of the queue? No. Basically this was when my queue size was 2. So for 1 I have already done. Now for the next iteration again, now my current right now is pointing to 3. So this is my current right now. Okay, but my previous is still at 2. So let me just remove it. I hope you are understanding. In case you are not, let me know in the chat. I'll just see after this. So previous is still pointing to 2 and current is right now at 3, because that was the peak of your queue. So you check this condition. Previous is not null as of now. Sorry, if previous is not equal to null, which is true. So what do we do? This is where I am creating the link. So previous dot next is pointing to current, and now previous itself has moved to current. Previous is our iterator. Okay, nothing else. Previous is our prev node is our iterator. Current is the node that we are removing from the Q and trying to form a link between previous and current, and then we are making previous point to current. Okay, this is the condition. Now from the next lines I am adding the left and right child of 3 also for the next level. Okay, I have added that. Then I check if this was the last iteration. Yes, this was the last iteration for this loop. Okay, so current dot next right, that tells me that I am at the last node of this level, so I want it to point to null. So this is what I am doing with that line of code, and I have successfully formed the links like that, and its next is null. Now again for the, you come back to this while loop, your queue is not empty, it has 4, 5, 6, 7, all the nodes that are present at this particular level. Okay, now what is the size of your queue? It is 4. So you run this loop again. Right now your current is 4, so previous is null. Definitely you are always creating a new node by name of previous whenever you're coming at the new level. Okay, and current is 4, so previous and current are pointing to 4. So from next there will be no left and right child further, so you'll just stuck up at, means you'll not go here, you'll just check the peak of your queue, remove it, form link, and that's what you're going to do at this level. Now in the next iteration you'll see that your previous is not null, so you form this link like this. Your current comes here, and current was there, and previous also points here. Then in the next iteration 5's next is pointing to, again you check previous is not null, so previous dot next right is pointing to current, which is 6 as of now. Both current was already here and previous is also now pointing to here. Then in the next iteration your current is at 7, because that will be the peak of your queue. One by one these will start removing, and then you see previous is not null, so 6 next will be 7, then previous points here, and in the next iteration, in the last iteration, you will make it point to null. So that is all about it. I hope you have understood this problem. It's also a simple one. You can see that it is completely as same as we were doing level order traversal, just a few additions. The few additions are how we are taking an iterator node which can form a link between the nodes at the same level. Okay, so I'll just quickly check if you there Shankar is saying I have solved I equal to, very good, that is correct, that's what we have done. What have I done here? My size was stored in n, so I have done it in the same way like you are telling. Okay, so I'll now quickly code it here, although I'm sure that you guys have understood and will be able to do it on your own. So let's start it. Let's create a node q of type integer, of node q equal to new linked list. Fine. Then the next step is I'll take while. First I'll add into my q dot add your root node. I'll add it here. Now I'll do the while my not q dot is empty. Okay, if that is the case, I check int n is equal to q dot size. Then next thing I do is I take my node priv pointing to null, a new node I am creating every time. So for int I equal to 0, I is less than n, I plus plus. Okay, this is what we are doing. Node current will be the node you will be removing from your q dot poll. We use poll, right? Pop is for stacks. Okay, then next thing is if I want to create the link, if previous is not equal to null, then prev dot next right is pointing to current, and after doing this thing I am anyway moving my previous to current node, correct? Then I check if my current dot left is not equal to null, I insert into my q dot add cur dot left node. Same thing I will do for right node. Okay, cool. Okay, and last thing was I was checking if it is the last iteration of this for loop. If that is the case, I want its next to be pointing to null. So if your I is equal to n minus 1, your current dot next right should be pointing to null. That's all. Let's check if it is correct. Why is it taking so much of time? Let's directly submit and check. I think it, yep, so it worked. Okay, so that is all about today's problem, everyone. No, there, Shankar, I'm not an instructor in any course as of now. I just take live. But I really appreciate guys who are watching it right now. Very good. And keep this dedication until you become a really good coder. So that is all about today, everyone. If you have any doubt, you can ask me. Thank you, everyone. Then if there are no doubts, I'll just wrap it up and see you all in next lecture, that is tomorrow. Bye bye and take care, everyone.